So all the statistics that we've learned so far, mean, median, standard deviation, IQR, those are all sort of summaries of a whole data set. A z-score is different because a z-score tells us how an individual data point fits in with the rest of the data set, or you might say where that individual data point is located within the data set. Specifically, a z-score tells us how many standard deviations a data point is from its mean. And this can be really useful for making comparisons across different scales. So you can see the formula is given there. It's just the value minus the mean divided by the standard deviation. In general, if a z-score is greater than 3 or smaller than -3, then we say that that's a very unusual point. And that could actually be another method of identifying outliers. So we have another one that's based on IQR. This one is based on standard deviation. So let's look at an example with real estate in two different markets. So certainly if you have two different real estate markets, those are two very different scales. And this real estate agent covers a neighborhood near Stanford called Old Palo Alto, and then also a newer neighborhood called Foster City. The average house price in Old Palo Alto is very high, almost $2 million, whereas in Foster City it's lower, $711,000 and change. So which would be more unusual, a $2 million home in Foster City or a $3.5 million home in Old Palo Alto? So these aren't immediately easy to compare because the houses are on such different scales. So that's where a z-score is going to be helpful. So let's start by calculating the z-score for the $2 million home in Foster City. So 2 million is 2 with 6 zeros. I apologize for these huge numbers. 711, 400 is the mean. So it is higher than the mean, and we're going to put that in terms of standard deviation. So the standard deviation is 318,177. And we end up with a z-score of 4.04. So this house is 4.04 standard deviations above the mean in its particular neighborhood, so above the mean in Foster City. So this is a very unusual point. This would be a very expensive house relative to this neighborhood. In fact, it's above the cutoff that we sometimes use for an outlier. So this is a very unusual point. And let's compare that to the Old Palo Alto house. So we're going to do the z-score. 3.5 million is 3, 5, and 5 zeros minus the mean, 1,930,436. So again, it's higher, but we want to put that in terms of the standard deviation. So we divide by 914,523. And when we do that, we see that this particular house is only 1.72 standard deviations above its mean. So standard deviations above the mean in Old Palo Alto, right? It's being compared to its particular neighborhood. So if the question is which is more unusual, this $2 million home in Foster City is actually more unusual than the $3.5 million home in Old Palo Alto. So z-scores are useful because they help give information about how a data point fits into its own distribution, how unusual it is relative to its own mean and standard deviation.